Thanks, Kavishka. Hey folks, it's an absolute pleasure to be here talking to all of you. Hope you had a good lunch. So without further ado, myself and Lakmal will jump into the more complex, the advanced parts of Choreo that we usually try to hide behind Choreo simplicity. And we'll look at how the platform engineering teams, site reliability teams, and basically enterprise operations can configure Choreo as a platform to basically enable DevOps, observability, and all sorts of site reliability engineering practices that are all built into the platform, right? So we'll start with a quick backstory. So you've been through 2 labs earlier. Effectively, you've seen how Choreo helps brownfield projects and greenfield projects sort of get into that into the practice of modernization. In the last lab, we looked at how you can develop a piece of code and push it through to a development environment where your builds are automated, your connections are automated, enabling developer self-service to sort of take a piece of code and have it deployed into a live environment without actually getting operations teams involved. And the backstory for our lab is basically you're now in a scenario where you've seen great success with your prototype applications because Choreo helped you get there, but now you need to sort of focus on the bigger picture, right? Your focus is now more on non-functional requirements because your applications are now serving critical traffic. You want to make sure your systems are reliable, they're secure. You want to make sure there's observability both for you as operations or a platform engineer, and you also want to make sure that there's sufficient observability and self-service capabilities in that regard for your development teams to carry out their day-to-day activities, right? So this is where we see the shift from being a startup, a smaller organization, just pushing your code through, getting it deployed on Choreo from the development perspective, to sort of transitioning into a more structured, less chaotic way of running software. So this is where the whole concept of platform engineering comes in, but I'll hold on to that for a second. Lakmal will take over, but before that, we'll just quickly go over the agenda for this lab so you know what's coming up next. So as I said before, Lakmal will introduce you to the concepts around platform engineering, just in case any of you are not familiar with the term, and then we'll jump into infrastructure. We'll talk about how you can use Choreo to create cloud infrastructure, manage your Kubernetes clusters, and sort of how all of that sort of fits into Choreo's ecosystem. Then we'll talk about environments and CI/CD pipelines. Now, in the labs and demos that you've seen so far, a lot of these were hidden away. So in this lab, we'll go in and take a look under the covers, and you sort of start to understand how everything is wired together underneath. Then we'll talk about zero trust and governance and how Choreo's network model and architecture just seamlessly enables you all of these capabilities out of the box. And then we'll move on to observability and site reliability engineering, as well as platform insights. And then we'll wrap it up with a Q&A. So without further ado, I would like to invite Lakmal.
Right. I think before I start, so I would like to ask a few questions. Can you raise hand if you are a system engineer? No. Cloud engineer? Platform engineer? Okay, few. Developer? Okay. DevOps role? Oh, okay. So let's see how all these things fit into the one piece. So let's start with platform engineering. What is mean by platform engineering? So basically, now like in the previous 2 labs, we demonstrated how the developer can do a lot of self-service capabilities within the platform. Now, mainly so that give a lot of productivity to developers to like in development life cycle, they can do a lot of stuff without interfering or engaging with the other people. To build this kind of platform, someone has to build it, right? So this is where the platform engineering comes. So the platform engineers or platform engineering concept is to build platform, ideally the most productive platform is the internal developer platform, but there can be different platforms. So build platform that help developers to do software development as a self-service portal. So so that's the platform engineering. So let's look at few things of platform engineering. So this is the maturity model of platform engineering released by the CNCF Foundation. So if you look at this maturity model, they categorize platform engineering maturity into 4 levels. First one is a provisional, then the operationalize, scalable, optimizing. So the provisional is something like there's no dedicated platform engineering team. So it's like within the organization, maybe there are some volunteering to do some platform engineering stuff. It can be after developer build their code their application, someone has to take it into the production and run it, right? So basically, then if someone has knowledge of how to create a maybe remote server in remote location, and they spin up maybe a VM or container, something like that, and they deploy the code into the production. So it's like a voluntary kind of engagement. There's no dedicated team, but it's again something like a categorized into the platform engineering. So it's a provisional level of platform engineering. Then, if you look at the operationalized platform engineering, in that concept, there can be a dedicated team. So maybe a 1 or 2 members team will take care of do the platform engineering stuff for the organization. And then when you come to the scalable, this is where the product concept comes. Normally, what happens in the provisional or operationalized, it's like if you are getting a requirement, we do something and make it run, right? When you think of as a product, that means it's not one ad hoc thing. Now, in the product means we need to evolve that product. That's the product mindset. So we need to keep thinking of how we can improve this platform. So it's a product mindset. Now, how we can bring the new features into the platform. It can be not driven by the developer or other person or requirement. It can be think out of the box and provide more capabilities, improve the productivity to the development teams. So that's the product mindset. So that level of maturity is within the UI organization. That's a dedicated team, and they think as a platform as a product. They keep evolving this platform. Then come to the optimizing level. So that comes like it's not only the product. Now it is an ecosystem. Even product feature onboarding, we need to engage with different personas. It can be a CXO level, what their requirement, and we get their feedback in the early cycles and improve into the product. So it's like not only the platform engineering responsibility to build this platform, it's entire organization responsibility build this platform. So that's the maturity level of level 4 is optimizing platform engineering. So ultimately, internal developer platform when you have the internal developer platform, either you build in-house in the maturity of level 4 kind of maturity. So now this is the hype cycle, Gartner hype cycle. If you are not familiar with Gartner hype cycle, so they release hype cycle for different categories, areas. What happened? They analyzed the industry and tried to map all the hype cycle, the areas into this hype cycle. So in the early stage of this curve is the new trending concepts are mapped into the hype cycle. Now, when the top of this curve, it's in the top in the hype. So basically, in 2024, as for the Gartner, so a platform like a Intel developer platform and the Intel developer portals are in the top of the hype. So everyone try to build platform, everyone try to use platform using platform engineering concept. Now, when you come down to the slope, after the peak is the slope, normally what happened in the market, there are, even though sometimes it's hype into the hype cycle, after such hype, the different technology or different ideas will be dropped in the hype cycle. And then the next uprise in the curve normally is like a maturing the concept or technology within the hype cycle. That means that concept is now much mature. Now other people are adapting to use in the wide variety of wide global adaptation into the industry. So in 2025, you can see platform engineering now taking the second hype. That means it's matured at some level now. People are now trying to use in their production. So this is another graph I want to explain to you here. Now, I asked who are in the system engineering, cloud engineering, and the DevOps and platform engineering. So basically what happened in 2000, like in early 2000, so I start my job as a system engineering and system administration, system engineering kind of background. So basically we did all the stuff. We install the OS, we get the machines, we install the OS, and we configure the network, and everything we done by ourselves. Then we install our application, production application into the that servers, and we manage. Now in early 2000, I mean in 2004, 2005 kind of timeline, Amazon introduced its AWS cloud. That's the first of IaaS cloud introduced. So because of that introduction, the system engineering or system administration role has changed. They step up another level. They become cloud engineers. Because now, because of Amazon introduction, no need to do OS installation or bringing up VMs, creating a AMIs or whatever. This all the system engineers, or they become cloud engineers. They try to create a cloud architecture by using the Amazon functionality. So they step up. So I think then we up to the 2020, 2020, this era, we use Amazon and other cloud providers, GCP or Azure. We use all these concepts, and we start building the platform there. So this is the platform engineers role emerge into the market. Now, what we believe, there's another shift happening, like a platform like Choreo, where now, so when you come to the platform engineering and building platform, it is not an easy. So I'm not going to discuss like a detail today. There's another session I'm doing on Thursday. So I will discuss how we build our platform, what are the complexity, and how we can overcome the challenges. So basically, building platform is not an easy, and it is a lot of investment, time investment, money investment, and we need to build a lot of knowledge in-house. It is not an easy. Because of that, vendors try to build platform and give that platform less experience to the industry. Then now this platform engineers can now become another step up, go another step up, consume the abstraction provided by these platformless platforms. They can become they operate their platform. So this is where the mainly Choreo we trying to solve trying to address this problem. We provide capabilities, abstraction to the platform engineers. The next level of platform engineers can operate this platform. So, yeah, let me go through some of the UI that we provide in the platform engineering in the Choreo platform. So, the last, I think April. So in the last two lab session, you saw that how the developer view the used in Choreo and a lot of functionality within the developer view. So last April we introduced this new view called platform engineer view. So the main reason behind this, now even now, like I said, now platform engineers will go the step up. Now they don't need to all the configure these tools manually. Choreo kind of platform will provide all the integrated experience. Now, but in the organization, they have to configure their platform to their suited to their organization. So to do that, initially we thought of, okay, within the same interface, we can provide some functionality, but after we engage with couple of, I mean the last 2 years with the customers, we realized that it's better to have a separate view for platform engineers. They can understand different terminology within their job role, and we can provide a first-class UI for them. It's very easy to navigate and configure their platform. So this is the platform engineering view, and you can see for the overview, you can they give the overview dashboard. It's give the first glance experience, first glance view to what happening. They can identify what happening in the platform, and so in the left-hand side menu, you can see different capabilities that platform engineers can do within the platform. Under infrastructure menu, you can add a data plane. Data plane is like a dedicated cluster they can attach to your platform. So normally it's a large organization. They may run on their data plane may run on different cloud providers, maybe in on-prem. So in this interface, you can attach your existing clusters to the Choreo platform, and then you can set up environment, and you can do a lot of domain mappings if the application required. So some of the capabilities Binura will go through detail. And the user management, where you can onboard your users, your teams. Basically, it can be configure your existing your IDP and configure to users to log into the Choreo platform. Then in the DevOps, under DevOps menu, it's more giving first-class experience with the concept they are familiar with, like a Kubernetes level concept. The developers doesn't want to know all these concepts because they want to write a code and run in production. But as a platform engineer or SRE point of view, they understand the concept. It's better if you can get use the same concept to understand what's happening in the platform. And in the DevOps menu is like setting up a pipelines. It can be CI pipeline, CD pipeline. They can use this menu. And also in the governance menu, I will come to the detail in the next session. So in the governance menu, where you can configure some of the workflows, because I would say if some sizable enterprise require a lot of workflows in the organization, it's not just every single person do everything. So we have to configure a lot of workflows, and then when you come to the real complex application need to enforce sort of like a policy enforcement. It can be a firewall setting up, it can be a authentication policy enforcement. So this is the interface they can use to enforce these policies. And also, like so this is where Kubernetes level concept they can directly interact with their user workloads, and then come to the observability and insight where they can monitor their platform, or they can configure the alerting capabilities against their user application. All are required when you're running a production grade application. Okay, so let me go again to slide. So that's the overview of what capabilities we provide as a platform engineering view. So it's a first-class user interface for platform targeting to platform engineers to control and manage their platform. Okay, I will hand over to Binura again. So Binura will go through some of this configuring up this pipeline and the data plane concept. Then I will take over the last step.
Thanks, Lakmal. Hi again. Am I vocal? Yeah. All right. So let's jump into the first part of the lab. We'll talk about infrastructure. So under infrastructure, we are going to cover two main components. One is going to be private data planes. Effectively, private data planes is how you connect a Kubernetes cluster to Choreo, and we'll look at that architecture in a bit before we dive into provisioning one. And then we'll also talk about platform services and the types of platform service enablement that is available inside Choreo. So yeah, without further ado, let's dive into the private data plane architecture in Choreo, so you kind of have a good idea of what this whole concept is about. Because as we go on to the other concepts like environments and CI/CD pipelines, a lot of them will be based on top of private data planes and data planes in general. So we'll just start here. So Choreo as a system is basically composed of two main parts, right? You've probably heard of this. The control plane is a SaaS. It's operated by us, WSO2, and we keep it up. We ensure uptime. We give you all the SLAs. So that's basically something you don't need to worry about, right? So the Choreo console that you've seen so far, the Choreo CLI, the VS Code extensions, all of those interfaces that your developers interact with, those are managed through the Choreo control plane, and that's managed by WSO2, right? And then you come to data planes. Data planes are of two types. All the applications that you've seen deployed so far were on the cloud data plane. Just like the control plane, we do, like we as in WSO2, we host a set of cloud data planes, meaning these are massive multi-tenanted environments where different users and customers can deploy their applications onto without actually owning the underlying infrastructure. Now that works for a lot of customers, but at the same time there are those of you that would prefer to have control of the underlying infrastructure, right? You want to run your workloads in your own cloud. You might have an AWS account, an Azure account. Heck, you might even have a on-premise data center that runs some Kubernetes distro like Rancher, and you want to run Choreo on top of that and deploy applications on top onto it. So all of that is possible with private data planes. So we won't get too deep into like the private data plane architecture and all that. As Lakmal mentioned, there is another session on Thursday, so we'll cover those then, but we'll just quickly go over the layers and sort of try and understand what a private data plane is, so it doesn't look like a complete black box. And I know some of you are platform engineers, and you'll probably realize the amount of effort that has gone into building a data plane or a platform of this sort. So this is what this is like the flat architecture. It's the schematics, if you will. I know Lakmal uses this a lot in his talks. You'll hear a lot more about this one on Thursday. But effectively, if you were to break this down into more digestible chunks, we like to think of a data plane as a set of sort of a layered solution. And at the base of it lies Kubernetes and a few primitives like networking, some networking requirements, some storage requirements, and effectively a Kubernetes distribution, right? Choreo doesn't manage the distribution, but Choreo builds on top of whatever the upstream compatible Kubernetes distribution that you have running. So this is layer 0, right? You can run a Choreo data plane anywhere. You can run Kubernetes, and you can plug in any cloud secret store, like AWS Secret Manager, for example, or you can run HashiCorp Vault, or you can embed that directly into Choreo, and Choreo runs that. Same goes for container registries, right? Bring your own, or Choreo will embed one for you. And all of that is orchestrated through a couple of mechanisms like Flux and Argo. Again, won't get into the details. All the tech is on the slide if you are curious, and we'll explore more in that other talk Lakmal is doing. But on top of that base infrastructure layer is what we call the observability stack. Now, this is something that sets Choreo apart from a lot of other platforms because it's a deeply integrated observability layer. Now, as you can see, we ingest logs both from the infrastructure level and from the layers that come on top of this layer, which we'll get into in a bit. We use things like eBPF, Cilium, Thanos, Prometheus, and a whole bunch of tools to sort of bring together a vertically integrated observability solution that can tap into every part of your infrastructure, right? And on top of that, we've got our CI system. We'll look at CI pipelines in a bit. That, again, is what allows all those, in the previous labs, you've seen the automagical builds, right? The developer connects their Git repo, they click build, it just magically builds something, and it gets deployed. So these are the things that power all of that magic behind the scenes. And even on the cloud data planes, of course, run at a different level of scale, and they're massively multi-tenanted. But some of these underlying concepts are pretty much uniform across the board. So the CI system is combined with the Choreo runtime. Again, if you were to bring your own Kubernetes cluster, this is how we convert it into a private data plane. We install basically a Helm chart that installs a couple of network gateways, a web app gateway, and a bunch of components that we call the Choreo system. And that is what orchestrates all the deployments, the applications, the promotions, the configuration management, the secret management, all of it, right? And then that also connects back to the Choreo control plane, the SaaS model. And this is what makes it the whole thing platformless, right? In the previous labs and in the previous demos, you probably were not aware that this level of complexity is what underpins the platform, right? It's all, so Choreo goes to great extents to hide that complexity from developers so that they don't have to deal with the cognitive complexity that is the behemoth that sits underneath, right? So that said, there are 3 ways to operate a PDP. One is a fully managed PDP, sort of like a private cloud. You click a button and we provision private data plane for you on a selected cloud. We'll look at that in the lab. There is also 2 other options where you can manage your own PDP, as in you bring your own Kubernetes cluster, you install the Choreo system on top, it gets converted to a private data plane, and then you manage it. But of course, VSWSO2 can't really help you with your uptimes, your SLAs, and all that on the PDP. That is your responsibility. And the third one is the managed services option, where our site reliability engineering team or one of our partners, take care of running a private data plane in your cloud on-premise infrastructure. So those are the options. And without further ado, let's jump into a quick demo. So that's a bit wonky. I'll try and stretch this out a bit. So the demo that I'm going to show you now is going to be what we call a one-click data plane. This is basically the private cloud option that we were talking about. For the other 2 options, we don't currently have self-service, but that will be available later in the year. But if you need that today, we have got customers on all the clouds running in all 3 of those modes. And if you're interested, just talk to us and we'll be happy to guide you through it. Now I'm going to set up a private data plane on Vultr. Vultr is also a smaller, more cost-effective cloud provider. We also support all the other cloud providers, but for now, I'm just going to pick Vultr and I'm going to create a small data plane. Again, now this is a fully managed data plane, and we just started the provisioning process. So underneath, Choreo is going to go ahead, run a whole bunch of infrastructure as code. Basically, we generate that, we run it, we create the actual underlying cloud resources, we install the Choreo system, we convert it into a data plane that connects back to the control plane. We then set up alerts and all the SRE functions for us to internally manage it behind the scenes. So this will basically operate as a cloud data plane, but you can be guaranteed that it is dedicated for your organization, right? So unfortunately, the problem is this thing can take about an hour because we are, actual provisioning actual infrastructure, setting up actual, real Kubernetes clusters behind the scenes. So I've gone ahead and set one up for the lab, right? But if you're lucky, we might see one by the end of the demo, but I'm not promising anything. So I'll just jump back into the slides here. So we'll leave that for a second, and we'll come back to platform services. Now this is the other part of infrastructure, right? Your Kubernetes and data plane is where Choreo runs your applications, but then your applications also need databases, queues, caches, Gen AI services, and other cloud services, right? So Choreo has two options. In the previous labs, you saw fully managed databases, basically MySQL, Postgres, Valkey is Redis compatible, and Kafka. So these are fully managed, meaning Choreo handles the upgrades, the backups, the high availability. Effectively, you don't need to really worry about running any of these Choreo managed databases in production, right? It's one of those options where you can just click a button and you just forget about it. The other option is if you're already running on Azure or AWS and you want to reuse your existing infrastructure as code, or you just want to use their CLI to provision a database or something else, Choreo has an option to do that through what we call automation pipelines. So we'll just quickly have a look at automation pipelines and platform services. So under DB and services, this is what you saw in the previous labs, right? This, through control granular permissions, you can allow your developers to create databases themselves, especially for like dev environments. As you can see here, I've got full permissions in this org. I can just provision Postgres, MySQL, or Choreo cache. I can also create like a managed Kafka service if I need to. I won't go ahead and create one because we won't really be using it. But we'll also have a look at automation pipelines. Now, automation pipelines is basically a pipelining mechanism, a general purpose pipelining mechanism. You write your pipeline and Choreo takes care of running it. And again, just like all the other management capabilities in Choreo, these run inside your data plane, right? So for example, we've got a example pipeline here. And if I look at the YAML, this is basically cloning a repository with, I know there's something on the screen right there, but hopefully you can see past the blemish. So we are just cloning a Terraform repository. We are running Terraform plan and then Terraform apply. We're taking some outputs. We are injecting some secrets. That is also something Choreo helps with. And we're taking some outputs from it. Again, we don't need to get into the nitty-gritties, but with Choreo, once you do set up a private data plane, you can sort of move away from bringing together multiple tools to simple tasks, like running a simple pipeline, a ETL, a batch job, or anything of that sort. So you can see some, oh, sorry. let me, yeah. Actually, this is a different one. So I'll go back to this example here. And if you just look at the logs, again, these logs, right? The pipeline runs in the data plane. Now this is a private data plane. And the logs are also extracted through that observability layer that we looked at before, right? So we have tight, deep vertical integration across the board. And that's what enables things, us to enable capabilities such as this. So basically, you can see we are running Terraform here. There's a bunch of stuff getting applied. I can zoom in. You need to have a better look. But yeah, this is just provisioning an S3 bucket and a few policies. But I'll close that up. And then again, you can easily, with the right permissions, manage configurations and secrets for your pipelines inside of Choreo itself, right? So there's no need for platform engineers and operators to jump through multiple tools to provision and manage your infrastructure yourselves, if that's something you want to do. So we'll come back to the slides here. I'll go back to the slideshow. All right. So that's a quick intro to managing infrastructure with Choreo. There's a lot more to it, but we've got a few topics to cover, so we'll move on to environments and CI/CD pipelines. So we'll have a quick session. We'll look at a few scenarios on the Choreo console itself, but before we jump into that, just want to take you through a few slides and sort of explain some of these concepts. So you're all familiar with the concept of an organization in Choreo, right? You've seen that in the labs and the other demos. So you have your organization and you have your projects, and then at the organization level, you attach your Kubernetes clusters as private data planes. Generally, for a production grade setup, you usually set up 2 clusters, and non-production cluster and 1 production cluster, but there's no limit on it. You could have as many clusters as your budget allows you to have, right? So once you set up a data plane, you can create what we call environments on them. Now, environments can be physically separated. Right? For example, you don't want your production environment sitting on the same cluster as your development environments, right? In fact, with Choreo, you can, to a certain extent, safely do that, because we use a lot of logical partitioning and a zero trust architecture that does allow organizations to actually do that. But for things like redundancy and high availability, it's generally recommended to have 2, right? So with Choreo, you can easily, with a click of a button, create as many environments as you want, and these environments can sort of span different data planes. So this is where Choreo's multi-cloud and hybrid cloud capabilities sort of come into play, and we'll have a look at this in a second. So if you've noticed in the previous labs, Choreo does a build once and promote strategy, right? We build your artifact, your container image once, and then we promote it across the different environments. Now the cool thing here is that your environments can be in different clusters, different data planes. In fact, they can be in different types of data planes. You can have your dev environment in the cloud data plane for cost savings. You can have your staging and production environments in private data planes. And when you do click promote, Choreo will actually take care of promoting that same image artifact across all those environments. And the flow that describes these promotions are what we call delivery pipelines or CD pipelines. We'll have a look at this in the lab as well, and as a platform engineer or as a platform operator, you can very easily create these delivery pipelines, and once you apply them into your projects, they just immediately get applied for your development teams, right? And one of the cool things with these capabilities is that Choreo gives platform operators a lot of autonomy and control over how their organization works. And when they do apply it, a lot of the time development teams are completely unaware of what's happening underneath, right? With the right permissions, actually, instead of trying to explain it in words, let me just go ahead and do that right now. So I've got one default project. I've got to just switch to the developer view. As you can see, I'm back in the developer view. You've seen this in the previous demos. And if I go into the deploy view, I've just built this Go application. I've deployed it to a development environment. And that's it, right? So I'll go back to the organization level view. I will go to the environments, right? So right now you can see that we have two environments on the Choreo Cloud data plane. This is where we've been deploying these so far. But we do have a new data plane. This is that private data plane that I created earlier. So I'll call this, create a staging. Let's call this PDP staging. Call that staging. I can mark it as a critical or production environment. I mean, it's up to you. I will not. I'll go ahead and create that environment. So with that, with the click of a button, I've now created a staging environment on the new private data plane. Now, to use an environment, you need to promote into it, right? So I'll go ahead and create a deployment pipeline. Let me zoom in a bit. So this pipeline right here is what you saw in the development view, right? As a developer, you see development and production. And this is that pipeline you saw earlier. So what I'll do is, instead of editing that pipeline, I'll create a new PDP pipeline. We'll go from the development environment on the CDP. We'll then deploy into staging, which is on a private data plane. And just to drive the point home, we'll then deploy back into the production environment, which is still on the cloud data plane, right? I'll go ahead and create that. Now I've created one. Now this is obviously not something we'd use in production, but this is just to show that multi-cloud and hybrid cloud capability. But I would rather, actually we'll just go ahead with this. So we've got that one, but I'll go back to my default project. Now this is where Choreo enables platform operators to operate at a much higher level of productivity, right? I've designed the CD pipelines that I believe are applicable to my organizations. And now as a project administrator, I don't really care about what's happening at the organization level, but as a project admin, I can see the pipelines that are available to me, right? So there's a new pipeline available to me, and I will add that to my project. Now once that is added to my project, I will go ahead and I will mark that as the default delivery pipeline for that project. And I'm still in the developer perspective, and if I go into the greeting service, and if I go into the deploy view, lo and behold, you'll see that the pipeline has now changed, right? Previously, we were looking at the development environment and then promoting to production. But as a project administrator, I just changed the pipeline, and staging is right here. And now, as a developer, I'm completely unaware of where my application is getting deployed, right? I just click deploy. I'll just reuse the development configurations. You've seen this in the previous demos, and I'll just promote, right? And that will go ahead and promote it into PDP. Now this should fail because I will need to create a new build. And one of the ways Choreo handles that multi-cloud capability is by building the same artifact and just pushing it to all the connected container registries, and then it coordinates the right image as you promote through the delivery pipeline. So I will trigger a build here, and as the build goes ahead, we will quickly come back here to CI pipelines. So CI pipelines is basically our build and deployment pipelines, right? So as you've seen again in the previous demos, this is a very auto-magical experience of sorts. Developers connect their Git repo, they click a button, lo and behold, even without a Docker file or any specification, Choreo uses cloud native build packs to create an deployable artifact. So Choreo can build an application or a service or an integration or anything that's written in any language, right? You can either use Choreo's pre-built build presets that you've seen. You can bring your own Docker file, or in fact, you can also deploy from an external container registry if you already got existing images. So the whole system is sort of designed for developer productivity, right? It just makes it very easy for developers to go ahead and create builds and push things through into development environments without having to get bogged down by unnecessary restrictions or having to create a ticket to get something simple as a build done. So we will now have a look under the hood at what powers the CI and the build pipelines in Choreo. Again, I will go back to the organization level. I will now switch back to the platform engineer view. Go back to DevOps and CI pipelines. Hopefully you can see. So these are all the default build packs that power that automagical experience. So out of the box, Choreo includes almost 20 odd build packs, and we are constantly adding more. But you, as a platform operator or platform engineer, can also define your own custom CI pipeline. And the way Choreo works is you define the CI pipelines at the organization level, and then it gives you great control and governance capability to keep things uniform across your org. If you've been in a DevOps role or in a platform role before, you know how hard this is, right? A lot of tooling has now pushed this onto the side of developers. Developers write their CI pipelines themselves. And some developers enjoy it, some hate it. But again, at the end of the day, you end up with this very non-uniform set of pipelines across different applications, right? And all of that, at the end of the day, adds up to your technical debt. And with Choreo, we change that around. So you define the CI pipelines at the org level. You can always add more or remove them as you need. And again, just like the delivery pipelines that we looked at before, at the project level, project administrators can go ahead and just choose to consume which pipelines they want to be used in their project, right? For example, one project might be just a backend team. All of their services are written in Java, so they don't really need all these other dozen odd build packs. So that project manager can just pick and choose the Java build packs, right? So as you can see here, a whole bunch of things you can filter through, and we're constantly adding more. So I'll look at a customizable example, right? So in Choreo's default build pack, you have a build, we scan using for vulnerabilities, and then we just push to the registry. And if you have auto deployment enabled, we'll just push it and deploy it immediately to your first development environment. But in this case, I've expanded it out a bit. We are going to do the build, and then we are going to do 2 parallel steps. We're going to run some Go tests. We're going to run a Go linter, and we're going to send out a Slack notification, and then there's some post-build steps. Now, all of this is described in this YAML. The specification will be available, and this is also a preview feature, by the way. If you are on private data planes, this will start rolling out in a few weeks. But effectively, you define your pipelines at the org level. We call this the Choreo pipeline syntax. And you can manage pipeline variables at the org level, and you can override them at the project level and at the component level as well. So if you do need some customization in your pipeline based on the project or the component, that is also possible. So I'll go ahead and add this, if I haven't already, to my project. As you can see, I've already added it to the project, but again, as a project admin, I can just pick and choose which CI pipelines I want to add to my project from the org level. There's nothing new here because I've already added it, but yeah, we'll go ahead with that. And if we go to the greeting service, and again, as I am in the platform engineering perspective, I have the ability to change the CI pipeline that's used to build this component. And with the permission model in Choreo, you can disable this for your developers, or you can just make one CI pipeline the default for your project, in which case developers don't need to think about it at all. So now my last build has failed, but if you look at the builds before that, you'll see we'll see the logs. As you can see, this is the results from the test that we ran, the Slack notifications, the linter. You can also see the build logs. There was no issue with the vulnerability scan, so we don't have a warning there. So again, as a developer, I would just click build and all of this would happen behind the scenes, right? I wouldn't have to get bogged down dealing with all this YAML and writing pipelines on all that, right? So this is how Choreo sort of enables platform engineers to operate at a much higher level than just wrangling with YAML and writing bash scripts and trying to pull all of this together, right? So that's customizable CI, and I know we went through a lot of concepts, but I will take a break here and invite Lakmal to take over the zero trust and governance parts in Choreo.
So I think, so as you see, like, so in Choreo, we provide a unified interface UI to do developer experience as well as the platform engineer experience. Like, so basically, if you are a platform engineer, if you are trying to use, so in the diagram Binura showed, we are using now 20 plus the CNCF project in this platform. And if you are familiar with these individual tools, to configure each and every tool, we have to build a lot of knowledge, and there are different interfaces, user experience, and you have to deal with all this stuff. But what, as a Choreo, as a platform, as a service, what we are providing is provide a all integrated experience with a very unique unified interface. Now let's look at the security architecture in Choreo. So now with the increasing of the microservice architecture, now there's a report I saw recently. Averagely, there are, I think, 11 microservices will be in production in like enterprises in a given month. New microservices. So when you are adding a new microservices, that means we are exposing threat surface. Basically, in security point of view, we have to protect all our services. When you are having a new service, we need to think of, okay, how we can protect, how we can secure. So now, if you want to do this in manual process, there are a lot of things we have to do. If you are creating if you are familiar with the Kubernetes, network policies, then each and every container or pod, we need to create a network policies. So this is very cumbersome workload in as a SRE point of view. But if your platform provide these capabilities out of the box and enforce these security by default, then it make SRE life easier. So this is the other concept we want to inbuild into the platform. So let me go through some of the UI and explain. I think this is a WSO2 org. I think Ramit showed this in the lab session 1. So I'm going to use same runtime diagram here and try to explain it. So this is the one of our the sales web portal we are built in-house and run on Choreo, on top of Choreo. So if we go to the architectural view, so this is the architectural view of that project. So how we generate this architecture? Because we provide the abstraction. So we are providing the abstraction called connection. So developer, we enforce developer to use this connection abstraction. So then if developer use this abstraction, this diagram is generated by looking at the code, source code. So the benefit out of this one is, I think Ramit also addressed that. So basically, when you are growing your organization with the number of developers, and as a manager or development manager, they can't go to each and every code and identify, okay, what dependencies having this project, what are the connection they made, and what insight happening in the code. So, but if you platform provide this information to the architect or development manager, then it is easy to understand this is what underneath what things are happening. So, so in this diagram, so this is the static view of the architecture diagram, and if I go to the actual runtime view, so this is the actual runtime view of the same project. So these lines are generated dynamically by observing all the traffic underneath. So we use like a EPVF CDM to connect collect all the data underneath in the layer 4 and layer 7, and we store all this data into time series database, and we can observe throughout the timeline and see what happened in this project. And so in this project, what you can see, there are multiple components. So it's a microservices. So whenever we deploy a microservices or component into the Choreo project, by default it apply we are applying a Cilium network policies. So when you apply the Cilium network policies, so all the network connections to that particular component, so underneath is a Kubernetes port, by default it's denied. No one can talk to this port unless all the other component within the same project we allowed. All the other external components can't communicate to the component running in another project. So by default we deny. And if you want to do all this stuff manually, every time you deploy a container, we have to manually apply. But in Choreo, it's inbuilt, not bolt on. It automatically happening. Now, then we have this concept called cell. We have the cell architecture. So we are what we are doing in the cell architecture. We group the component that run together and deploy in this single concept called cell. Translate into the Kubernetes, it's a single namespace and protected via a Cilium network policy. So within the project, each component can talk to each other, and if you want to expose some of these microservices to the external, it can be external to the organization, we call it public API, or external to the project, internal to the organization, it can be an internal API. So we have two API gateways attached to this Kubernetes namespace. It's a virtual boundaries, and we only allow traffic coming to gateway to this running port inside this project. All other network are denied. And so it apply by default. So this is one of the zero trust principles, where microsegmentation. So we provide microsegmentation as a default, as a project level. So each component in that project provides microsegmentation, and all the traffic coming to inside this project is authentication or authorized via a API gateway. There is no unauthorized traffic coming to the project. So, and also communication in between these components are transparently encrypted in the transport layer. We are not using user doesn't want to configure MTLS certificate to do the MTLS encryption. We use Cilium underneath Cilium service mesh with the WireGuard encryption. So port to port, the network traffics are by default encrypted. So if you want to do this kind of thing manually, you can think of how to do. It's a lot of steps you have to follow, and a lot of cognitive load pushed into the either SRE or DevOps or even developers. So we take out all this the load and we make it default in Choreo. Then, so I think this diff also, I think Ramit also showed briefly. So in this diff mode, that means static view versus the dynamic view. So this is very very good feature. Even WSO2, we started using Choreo into our internal labs, and our internal labs team try to create microservices in their project, and then we realize after some times when you are keep developing the applications, some connections or some endpoints we are not using anymore. So it's a technical debt we have to deal with. But no one knows there's a connection we are not using. But with this underneath in-depth observability we provide from the CLM layer to the architecture diagram. So basically, project manager or developer manager, or they can identify, okay, we are building a technical debt because we are not refactoring our code, or we are not removing our old connections. So that again security exposing a security threat eventually. So basically we have to, this provides a lot of information. Then development manager can easily talk to the developer and say we can refactor the code. The other thing is if there are red line, if you detect it in this project or the dynamic view, that means some unauthorized network call happening that we not expected in the design view. So either we need to it can be some compromisation within the that container, and someone try to call someone else something else within this project. So that's also detected. We can make it alert also, and so that also we provide as an observable layer. Now imagine now, so if you are into the cybersecurity, and if you are subscribed to a cybersecurity newsletters, no, I am getting like a weekly lot of data breaches, right? So what happened normally? Either it's an inside threat or something like that. Someone can expose data from your organization to outside. So how we can control this stuff? So we have to trust developers. Then we don't know. We can't do every PR to do that, right? Every PR check we can't identify this thing, because sometimes we need to expose to the external. So we have to enforce some kind of policies here. This is where Choreo also provides this egress control feature. You can control your egress traffic either org level or project level. For org level, you can say, okay, within my organization, I am only allowing to talk to GitHub or maybe AWS. That's all. I am denied every other traffic. So as a platform engineer or maybe a higher level of system, the platform administration can enforce these policies in the org level. So let me switch to this one. So I'm in the platform engineer view. If I go to the governance section, this egress control. So I'm in the project level. So let me go to the org level. So if I go to the org level, I can set up two types of policies: allow all or deny all. So whenever in the org level, if I set some of the policies, it enforced to the project level. If I allow something into the org level, in project level, I can deny some of the allow list and make it more fine-grained control in the project. Other way around, if I deny, in the project level, I can deny some endpoints, external endpoint, and allow whitelisted endpoint. So that level of flexibility we can give to the platform engineers. They can do high level, just matter of like configuring a rule. But underneath, how we can do, we are using CLM network policies again. And now, without having this kind of abstraction, without having this kind of interfaces, it's pretty hard to do in operational. So every time when you deploy, when a new project comes, as a human, we can mix this, right? So, but if you enforce in the platform level, it's governed. So this is where the very important thing in platform, when you are building platform, governance is a key critical part that we need to think. Yeah, I think I covered that part. We have a few more minutes. Yeah, so this also I covered in some level. So the underneath we have the, like Binura says, we had a very deep observability inbuilt from the different layers. So here, so let me go again to the platform engineering view. Now, when you come to the monitoring and alerting, so this is a key operational as SRE, right? When you deploy your application in production, now we have to make sure it's running, right? If it is something happen, we need to make it alert, and then some in Kubernetes, many cases we can auto heal some of these issues, but some cases we need to alert to a SRE to attend to that incident and make it like a resolve. So in observability, before go to the observability, in the Kubernetes operation, normally even in the you can create different health check very easily without making providing YAMLs manually. So you can have you can configure your health check against your application. So recently, one of our customer migrated from VM to Choreo. So they use Nagios monitor system previously, and now they are fully using Choreo monitoring and alerting. They shut down their Nagios system now. So everything what they did in Nagios, they can do within the Choreo. By default, all these health check policies, health check are creating, but they can fine tune with the different application level configuration. And then go into the alerting menu in the under observability. So they can create alert with the different rules. It can be a latency-based alerts, it can be error-based alert, it can be like a CPU metrics-based alerts, and that give a lot of operational simplicity. No need to manually set it up, just matter of like choose a couple of drop downs and make it configured. Then it will automatically generate alert. It can be sending an email, it can be sending a SMS or something like that, PagerDuty. So it all support through the platform engineering view with the Choreo. Okay, I think so. Since we started a bit late, so we try to squeeze all the things into the 1.5 hour time. But I think we try to wrap it up. So basically, the message is like I said, I think while I sitting there, while Binura talking, Binura use this platform operator. That's very good term. We can use the next level of platform engineer, like a system engineers become cloud engineers when AWS introduced. I think now with the like a platform like Choreo, platform engineers can become platform operators. So basically, they give step up in their job role, and rather building platform themselves. Like I said, it is not an easy, but they can become platform operators. In platform like Choreo provide a lot of high-level abstraction and interfaces and unified experience to manage their platform. Then that become very easy their organization to make it more productive and make it more productive to their developers as well. Okay, so I think we can wrap it up. Any questions if you have? I think that's it. Thank you very much.